We're going to now go ahead and answer question 45 and 46. Question numbers 43 and 44 we did in the last video, and we're dealing with a projectile motion question. We're looking at an equation of a rocket as it is launched straight up into the air and how it goes to different heights at specific measures of time. So t is our time, y, the y value is how high the rocket is at a particular point of time. We've, I think, already recognized this is a standard form quadratic. So let's take a look at question number 45, which asks, at what time will the rocket reach its maximum height? At what time will it reach maximum height? We went through this in class of identifying what these questions are asking us, because sometimes it's not the math that throws us off. It's really knowing what is it asking us to give it. Well, let's think about this. We're looking at time and maximum height. We learn that when you see the word maximum height, we're talking about a vertex here. If I drew this graph out, just sketch the graph of the actual model rocket, we know this rocket is starting at 10 feet above the ground. There it is on the platform. It's being launched straight up, and as it travels in time, it's going to go higher and higher and higher. It's going to reach a maximum point, then it's going to come back down until it finally lands on the ground. And when we graph this, we typically graph time, or t, on the x-axis, and h, or the height of the rocket, on the y-axis. So if we're looking for maximum height, we're actually talking about the vertex. Here is where the rocket reaches maximum height. And if you draw a dashed line straight down, you would see that this point right here is the time at which the rocket reaches maximum height. So for this particular question, we're being asked for the x value of the vertex. The x value of the vertex. And we've learned that the equation for the x value of the vertex is negative b over 2a. Whoops, I wrote a. Negative b over 2a. Let's take a look at our original quadratic equation here in the question. We can identify, class, that a is equal to negative 16, and b is equal to 80, and c is equal to 10. So now let's go ahead and plug in our values. B is 80, so negative b is negative 80. A is negative 16, so we've got negative 80 over, or negative 80 divided by 2 times negative 16. That's going to be negative 80 divided by negative 32. Let's go ahead and put that in our calculator. Notice the negatives cancel. We're going to end up with a positive number here. If we load up our calculator, we have got 80 divided by 32, and our answer is 2.5. 2.5. So our answer for the x value of the vertex is 2.5. And look at our unit of measure. T is in seconds, so it's 2.5 seconds. So our model rocket is going to reach maximum height at the time 2.5 seconds. I'll go ahead and put a box around that answer since I'm running out of time here, and I'm going to need to go to the next video to do question number 46.